Okay, so good afternoon. By the way, I'll be discussing about the last topic that I gave you, which is memory system design. First of all, before we go deeper onto cache mapping, I would like to discuss simple ideas about memory hierarchy. So, just to give you a brief introduction or brief idea on why do we need to discuss about memory hierarchy, let's first look at the different technology in year 2021. As you already know, there are new releases of microprocessors, RAM, types of hard disk, and capacity of hard disk. So let's take a look at how does a data is being transferred from our hard disk or auxiliary memory or auxiliary storage to our CPU. So imagine this is the CPU. So we have the CPU. The next, we have a certain cache. Then we also have our main memory or the so-called RAM. Then of course, we have auxiliary memory or andito na si hard disk, si um, network drive, dyan na lahat. So flash drive and so on. So of course, it is connected via I/O processor. So ayan, connected po yan. Now, imagine if we have the latest CPU. So usually, the latest CPU process instruction in nanoseconds. Let's assume that the speed of our CPU, mabagal na po ito is 1 nanosecond. 1 nanosecond. And the speed of a hard disk, a flash drive, and so on is, imagine we have 1 microseconds. And for RAM, that is, imagine that is 100 nanoseconds. And for cache is 10 nanoseconds. So, sir, ano po itong mga nanoseconds, microseconds, and so on na yan? This is the speed in processing information. So, kumbaga, pag ang CPU natin ganito kabilis, and i-access niya si hard disk, kukuha siya ng information kay hard disk, at ang speed ni hard disk natin is 1 microseconds, kahit ganito po kabilis si CPU po natin, 1 nanosecond, so kaya niya nang mag-process ng instruction in 1 nanoseconds, pag mag-a-access pa rin siya ng information kay hard disk, kailangan pa rin po niyang mag-antay ng 1 microseconds. 1 microseconds. Nawa? So, ibig sabihin, ito para mas naintindihan nyo. Pag si CPU, kaya niyang mag-process ng information within 1 second. Convert natin into 1 second. Now, si hard disk, kaya niyang mag-process ng kaya niyang mag-access ng information within 1 hour. So kahit ganun kabilis po si CPU natin na kaya niya mag-process ng instruction within 1 seconds, pag mag-access pa rin po siya ng information kay hard disk, mag-aantay pa rin po siya ng 1 hour. Now, to lessen the time of time needed to access information, meron po tayong tinatawag na main memory and we have cache. So in terms of the speed, makikita nyo naman na po siguro, this is just a sample given speed. So kumbaga, from hard disk, ilalagay natin yan kay RAM. And from RAM, ilalagay natin kay cache. And from cache, ilalagay natin kay CPU. So pag nakalagay kay cache, yung information na needed, then of course, ang aantay niya lang po is 10 nanoseconds. In comparison with 1 microseconds. So pag nakalagay rin kay RAM, Then, ang time needed niya po is 100 nanoseconds. Diba? So, that is the basic idea on how do we on why do we need to study the hierarchy of memory. So, just to give you an idea about the hierarchy of memory po natin, and of course, ang nasa baba po natin is the auxiliary memory. Then, we have the main memory or RAM. Then, of course, we have cache and then level 2 cache because we have two levels of cache. That is the level 1 cache and level 2 cache. Of course, yung level 1, mas mabilis po yan. Level 1 cache and then we have the registers. So, in terms of speed, papataas po yan. But in terms of capacity, pababa po yan. Para malitad. So, ayan, tama. In terms of capacity, so, baliktad pala. In terms of capacity, pababa yan. In terms of speed, ganyan po yan. So, this is capacity, baliktad. In terms of capacity pala, papataas yan. And in terms of speed, pababa po yan. So, this is speed. And this is capacity. So, ibig sabihin po, mas malaki ang capacity po nito. Itong auxiliary memory po natin, yung mga hard disk po natin, mga flash drive kasi umaabot na sa terabyte. While our registers, nasa kilobytes lang po yan and so on. Same with cache. Bytes lang po ang capacity po nitong mga to. Okay. So, that's the basic idea of memory hierarchy. But for now, let's focus on to cache. The term cache refers to safe storage po natin. Kumbaga, safe storage. Imagine, ito po, napansin nyo siguro yung mga laptop nyo or mga computer po ninyo, the first time you open a file, medyo matagal mag-open yung kwan po natin. Imagine, nag-open kayo ng Microsoft Word. The first time you do it, medyo matagal. But the second time, so medyo mas mabilis na, parang na-lessen na yung time. Kasi po, usually po, ang ginagawa po ng computer po natin, meron po kasi tayong tinatawag na reference of locality. Reference of locality. And we have two types of locality. That is, we have temporal and then we also have spatial. So, temporal is time. Spatial is space. Sir, ano po ibig sabihin yan? What does this mean? So, when we are talking about reference of locality, kagaya nga ng sinabi ko kanina, yung imagine opening a certain file, the first time matagal. But the second time, bumibilis and so on. Kasi po, ang ginagawa po ng computer po natin, yung mga ginagamit po natin or para mas mapabilis po yung mga processing po natin, mas mapabilis po yung processing natin or process po natin of information, ang ginagawa po ng computer po natin, there are files na sinasave niya po kay cache. Sir, hindi pa rin po namin gets ang cache. Ganito po yan. Imagine if you have ito. And imagine a certain person. Imagine a certain person needed to fetch a certain object. Needed to fetch a certain object. Imagine, we have a table near the person, a room, and then another building. Okay? So this is a table, a room, and building. So if the person or if the object needed by the person is nasa table niya lang po, of course, the time needed to fetch that object is lesser. So pag nasa ibang room naman po siya, of course, maglalakad siya papunta sa isang room. So the time needed for that one is mas matagal na naman. And of course, for other building. Ngayon, ang ginagawa po natin, pag nanggaling yan sa isang building, of course, ilalagay muna natin into our room. So, pag kailangan natin, ilalagay natin sa table. Of course, pag nasa table, mas mabilis po natin siya i-access. Now, imagine, yung sinabi ko kanina, reference of locality. When we are talking about locality, ano ba yung mga file or ano ba yung mga instruction or data na isi-save mo po sa cache po ninyo? Ano yung mga isi-save mo sa cache? So, yung analogy ko kanina, this is CPU. Imagine this is cache. This is RAM. And this is auxiliary memory. So, our basis in locality or storing file into our cache is based from we have two types of locality. Yung sinabi ko nga, we have temporal and spatial. Sir, what do we mean by temporal locality? Okay. So, imagine this is the data po natin. So, ito yung mga data or requests na mga ginawa ni CPU po natin. So, A, B, C, then A, then F, then G, then A. And so we are talking about temporal locality. Temporal locality. So imagine these letters as information or data accessed by the CPU or request by the CPU. So the first time na nag-request siya, ni-request niya si A. Then ni-request niya si B. Then si C. Then again si A. Then si F, si G, then si A. Ang ibig po sabihin ng temporal locality, the frequently accessed information is yun po yung isi-save mo sa cache po natin. So kumbaga, si letter A, ilalagay na natin kay cache kasi lagi siyang na-access. O imagine this one. Di ba parang kumbaga is, ano ba yung mga information na kailangan po natin? Ganito na lang. So, imagine an information yung driver po ng kwan po natin. Driver of headphone. Yung driver ng headphone po natin. Driver ng headphone. So, the first time na ginawa mo is nag-open ka ng music. Then, the second time, nag-open ka ng movie. Then, the third time, nag-open ka na naman ng another music. So, every now and then, kailangan mo yung sound mo. Or kailangan mo yung driver ng sound mo. So, ang gagawin po ng computer po natin, isi-save niya po yung driver po natin into cache. Para the next time na kailanganin mo, is mas mabilis na lang po siyang i-access. That is temporal locality. Okay? Temporal locality. Then we have spatial locality. Spatial locality is from the word space. So, kumbaga, kung ano yung mas malapit sa'yo, imagine this one. Okay. Imagine, if the CPU in-access ni CPU si A, and ganito yung pagkakaayos niya sa memory. So, A, B, C. So, pag in-access natin si letter A, okay, ang sinasabi po ni spatial locality po natin, if you access A, then there's a possibility na i-access mo din si B. Kasi malapit lang si A kay B. That is spatial locality. Just to give you an analogy. Imagine we have 1, 2, 3, 4 students. So, ito mga students na to, nasa iisang row. Ayan. Imagine pag pinag-recite ni teacher si student number 2. Si student number 2. So, pag pinag-recite ni teacher si student number 2, there's a possibility na magre-recite din si student 1 and student 3. So, if that's the case, 1 and 3, yung 1 and 3 po natin, isi-save na po yan natin sa cache. So, ibig sabihin yung mga malapit sa kanya ng location for the previous access of information, di ba may in-access tayo? Kung ano yung mga mas malapit sa kanya, then there's a possibility na ma-access din po sila. So, ang gagawin po natin, isi-save natin sila sa cache po natin. That is the idea of spatial locality. Okay? Okay, next. So, we are already done with the reference of locality. We have the temporal and spatial locality. Now, I'll just discuss cache hit, and cache miss. Cache hit and cache miss. So, we have these two terms po natin. So, when we say cache hit, take note when we say cache hit, so if we request or the CPU requests an information and search for the cache, then the data is located into our cache. Now, to get our ratio, that is, wait lang. I should define first cache hit and cache miss. Anyway, dinefine ko naman na po sila. Ang ibig sabihin lang po ng cache hit po natin, define lang natin, sulat lang natin definition. So, cache hit is the probability of finding the info into cache. Then, cache miss is probability of not finding. So, kumbaga, yung information na kailangan mo is not located into the cache. That is cache hit and cache miss. Now, we have already defined what is cache hit and cache miss. Now, in getting the ratio of cache hit or hit ratio, that is the number of hits over the number of attempts. So, the same with cache miss ratio, cache miss ratio, that is the number of miss all over attempts. Or basically, this is one minus cache hit ratio. So, cache hit ratio, I repeat, is hits all over attempt, while cache miss ratio, that is miss all over attempts. Or basically, that is 1 minus cache hit ratio. Okay? So, for the next video tutorial, bibigay ko po sa inyo, that is the memory mapping, and at the same time, replacement techniques po natin. I'll discuss FIFO and LRU in the replacement techniques. But I'll discuss first the memory mapping natin before we go on to the replacement techniques. So, that's all. Thank you.